Hello and welcome back again. So our next speaker for the day is Jad Joubran, and a bit introduction about him. Already, he's a freelance web consultant based in Amsterdam, and in the last 2 years, he's been focusing a lot on teaching developers programming, JavaScript, and React through his online courses. And welcome, Jad. It's a really pleasure to have you, and the stage is over to you.
Thank you. Thanks for having me. Hey, everyone. My name is Jad, and I'm going to talk to you about the JavaScript prerequisites that you need when learning React hooks. So, as you may know, React is a front-end framework or a library, and like any other library or front-end framework, it builds on top of JavaScript concepts. So I think it's important to be able to recognize those JavaScript concepts so that if you're struggling with them, you can take a step back and know that you need to study these concepts separately from React. So this talk will cover these JavaScript concepts for React hooks, thus I won't be covering any classes. If you have any questions throughout the talk, don't forget to put them in the chat and I'll get to them at the end. So these are the 5 concepts that I'm going to talk about. You have the JavaScript concept, and then in the red or orange color, you have the React usage. So I'm going to cover automatic semicolon insertion, ASI, and how this affects returning JSX. I'm going to talk about object destructuring that we're going to use in props, array destructuring that you use a lot with the useState hooks, immutability that affects your state updates in React for arrays and objects, and finally closures, which is most likely something you're using without really noticing oftentimes when you have state and events in React hooks. So let's start with the first concept, and that's ASI, automatic semicolon insertion. I think you already know that semicolons are optional in JavaScript. You may be writing some code and you forget a semicolon and it works, and that's fine. However, there are some scenarios where the interpreter for JavaScript will automatically insert semicolons for you automatically. This is called ASI, automatic semicolon insertion. And some of the most important ones are after let and const, after import and export, after keywords such as continue, break, and throw. But the most important one is after the return keyword. So let me show you an example in JavaScript. By the way, the slides will always show you something in JavaScript and then at the end show you how it affects a React component or a React example. So if I write this code, function get age limit, and I define a variable let age equals 18, and I don't put the semicolon, this is fine. But then I have a return, and then on a completely new line, I have the age. What do you think this function will return? It's going to return 18 or something else. So this function will return undefined because of the ASI, because of automatic semicolon insertion. So the after the return, JavaScript, the interpreter for JavaScript will automatically place a semicolon. So this ends up with a result we didn't expect. We end up with something that we didn't expect as a developer. Why am I getting undefined? I'm returning age. So that's because of the ASI. So to fix that, you can of course put the age on the same line. That's most likely what you want. But a lot of the times, especially in React, when you have a very large return, because we're returning JSX elements, you do want to keep it on another line. And so for that, you have to put parentheses. As long as you have the parentheses, the opening parentheses on the first one, as soon as you have the parentheses right after the return on the same line, then the ASI will not place a semicolon over here because it knows that you are returning an expression. So it has to wait until the closing parentheses. So this is why this code works. So if you want to return on a new line, you wrap it with parentheses, and then you can have multiple lines. Now, let's take a look at an example in React. So I'm importing React from React, and I define a function app. So this is the app component, and I return, and then on a new line, I return the main HTML element and then the H1, but this will not work. This will return undefined. And you will see a warning about it in the console because If you intend to not return anything from your component, you need to return null. But anyway, in that case, this is caused by the ASI. We didn't mean to return null or undefined. So to fix that, you have the parentheses, you put the parentheses over here, and that's gonna work. So I think you've probably seen this code over and over again. This is another example. You have the parentheses, and then you have the React fragment. And maybe you're wondering, why do we have these parentheses? So this is because of the ASI. Now, on to the second concept, and that's object destructuring. I don't know if you can hear some purring, but there's a cat on my lap right now. She doesn't know React though. So object destructuring is another JavaScript concept. Before object destructuring, let's assume we have a point object that has the latitude and the longitude key value pairs. If you want to read both the latitude and the longitude, you would define a variable const lat equals point.lat, const longitude equals point.lng. With object destructuring, you can do all of this in one line. So I've commented out the previous code. Now we use a const, and we use the object destructuring syntax, which is curly braces, and then the keys that we want to pluck from the object point. So const, and then get the latitude and the longitude from the point object. So these two codes, the commented one and the one below, are the same, but just different syntactically. And this is object destructuring. Object destructuring also has an additional feature, which is giving default values for keys that may not exist. So in this example, if I destructure the latitude, the longitude, and the elevation, and I give it a default value of equals 0, when the elevation does not exist in a point, then we will get a default value of 0. So this is the JavaScript concept. Now let's take a look at React. Your functions receive a props, and the props is always going to be an object. And that's even if your app, can maybe use the pointer. That's even if your app over here, that's even if your app over here is not, doesn't have any props. So the props will be an object, and it's going to be an empty object. Now let's take an example where we render an app with a title equals my app. And in that case, the props will still be an object, but we will get a key value pair for the title. So it's an object with title my app. And let's say we just want to render this in a div. We render a div with props.title. Now this gives us the opportunity to use object destructuring. And if you look at other people's code on the internet, you will very often see this. So const, and we destructure the title from the props. And you can do that because the props is always going to be an object. And then you can immediately render the div with a title variable. So let me give you a before and after. This is before. You render props.title, but then if you know you're going to use the title several times, you can destructure it and then just use the variable title. You can even go a step further, and you may not like this. It's a bit opinionated. Some people don't like this, some people like this. You can destructure in the function arguments. So over here, we don't even define a variable props. We immediately destructure in the function arguments. This is a little bit tricky because as soon as you start destructuring 4 variables, the argument syntax becomes quite complicated. So you don't have to use this, but I'm quite sure you will see this someday when learning JavaScript, when learning React. So it's important that you understand this syntax. So we have, so over here, we immediately destructure the title from the props, but in the argument. So this code is pretty much similar to this one, but just shorter. Now let's take a look at another example. When you're building UI kits, for example, let's say we're building a button, so a custom button function component. So this is why it's button with a capital B. And this button will return an HTML button element. And then you take the class name from the props and you render that. You take the disabled state from the props and you render that. And then the text or the text content, you render that as props.children. This is something very common that you might use when building UI components. But there's a problem with this one. What if you need to provide a tab index? What if you need to provide another prop that we didn't think about? You can do that with destructuring as well. So because the props is an object, you destructure from it the children, and there is a way to destructure all of the other key value pairs that were provided. You do that by using the ... and then whatever you want to call it. I call it rest. So destructure the children and all the other props, all the other key value pairs that were provided, and put them in a rest variable. And now I can render a button with the children, and then I take all of the other key value pairs and I spread them on the button. So that way, if the user passes a class name, if the user passes a tab index, a disabled state, an ID, all of these will pass into the button. And this is often useful when you're building a UI kit because you will have a button component that renders state, that renders the button, but with your own custom styles and maybe custom behavior. Onto the third one, and that's array destructuring. So array destructuring is a little bit similar to object destructuring. I would also say slightly easier, because with array destructuring, you're pretty much relying on the index of the items that you're destructuring. So let's say we have const coordinates. It's an array of 2 items. Instead of reading the latitude, which is coordinates of 0, longitude, which is coordinates of 1, you can destructure them in one line, const, and now we use the array syntax, array destructuring. Latitude and longitude, we destructure that from the array that is the coordinates. And then if you console log the lat, you will get the first item of the array. So that's the JavaScript concept. And now I'm going to show you the same thing, but let's assume we have a function getCoordinates that returns a hard-coded array of coordinates, for example, 52.36 and 4.89. Since the getCoordinates function returns an array, you can destructure the result of that array on the same line if you know that it always will return an array of 2 items. So this is why the syntax is possible. Const, destructure the latitude and the longitude from the getCoordinates result, and the getCoordinates result will always return an array of 2 items. So if you've done a little bit of React hooks, this is probably very similar to you because of the useState function. This is a pseudocode of how the useState function looks like, extremely oversimplified, so you can say also wrong. The function useState will have the current value and will have a function that allows you to update that. And then this function always returns an array of 2 items, the current value and the function that allows you to update. And this is exactly why when we use the useState function or the useState hook, we destructure the count and the set count. So this is an example, but you always destructure the current value and the function that allows you to update. So one example is count and set count, seconds and set seconds. And yeah, that's because it's always going to return the current value, an array of the current value, and the function that allows you to update that value. So now let's take a look at an example of a component. So we import React. So you have to import React because all the JSX is using React.createElement. So this is necessary whenever you use JSX. And we use the named export to useState from React as well. And let's say we have a component stopwatch. And at the top of that component, we use the hook useState. We give it the default value of 0. And then the useState will always return the current value and a function that lets you update that. And you can call them whatever you want, but if you call the first one seconds, you will most likely need to call the second one set seconds, because then you know this is the function that updates the seconds. And another example is the button component. If you want to have some kind of enabled disabled state, you can call the useState hook again, and you don't have to pass in a number, you can pass a Boolean, and then you destructure disabled and set disabled. Disabled is the value, and set disabled is the function that updates it. And one more example here. We build on top of the previous example, but when you click, so we added an onClick, we call the function handle click, and this handle click will call the setDisabled function, so the function that is given by the useState hook to update the value of disabled, and we use the exclamation mark disabled, and this is a way for you to invert the false into true or the true into the false. So this will give you a button that you click on. It's not disabled, you click on it, becomes enabled, it becomes disabled, and then theoretically, if you click on it again, it should be enabled, but you can't really click on it anymore because it's disabled. Now onto the fourth, immutability. And this is a JavaScript concept that affects React quite a lot. So I think this is a very important concept. Let's take a look at these examples. If you take 15 and you compare it to 15, so number 15 to number 15, and we have a triple equal in between, you get true, and we expect that. String hello triple equals to string hello, we get true as well. True triple equals to true, we also get true because these values are exactly the same. However, it gets quite messy when you compare an empty array to an empty array. So you get false. But how is an empty array not equals to an empty array? Or an empty object not equals to an empty object? Or an array of 10 not equals to an array of 10? And this may look very confusing, but there's a way to simplify that and explain it. That when you create an array with the square brackets, you're creating a new instance of the array class, the built-in array class in JavaScript. And when you replace array triple equals to array with new array, so when you place square brackets triple equals to square brackets with new array triple equals to new array false, this starts making sense because each one of them is a new instance, is a separate instance of array. So this is why they're not the same. So we're not really comparing the values inside. We are just comparing if they are the same instance, more or less. And the same thing applies to objects. Now, why am I mentioning that? Let's take a look first at a wrong example in React. Let's say we have an app component that has a data state, which is defaulted to an empty array. And then we have a button. And when you click on this button, it says add 10. So this should add 10 to the array. So on click, we call the handle click function. And in the handle click function, we take the data array and we dot push to it 10. And then we call set data, and then we pass the data to it. Keep in mind, this is a wrong example. It won't work. Actually, if you try this and you click on the add 10, and let's say you were rendering the data at some point, it will not re-render. You will not see the value, the new value of the array. So it will, the React will never re-render. So let's take a look why. To take a look why, to understand why, we have to zoom in on the set data function. And again, this is extremely oversimplified just for the purpose of explaining. Let's say the state is initialized to an empty array. So this is created by useState of an empty array. And then the set data function will take the new state. So this was the result of data.push 10 when we clicked. However, React will start by checking, is the state triple equals to the new state? So is the old state triple equals to the new state? And if the answer is false, it will immediately quit and it won't re-render because React thinks that the state has not changed. And in case this doesn't return true, then it's going to continue. It's going to store the state for the next time, and it's going to ask React DOM to re-render. So now you might be wondering, why is React using triple equals? So why does it use state triple equals to new state? That's because React will have so many components, and it will need to check quite a lot of children a lot of time if they have updated. And they have to use the fastest option that is available in JavaScript, and that's triple equals. If they were to do the deep equal, which doesn't even natively exist in JavaScript, you'd have to have a library for it, all of our apps would be extremely slow. So now, because React is using this triple equal, we cannot we cannot dot push because when you're pushing on that already existing array, you're basically comparing the same instance of the array. And so state and new state will be the same instance. So in that case, it's always going to return true. So React will always think, oh, this array, this state hasn't changed, so I'm just not going to re-render. And this is why the data.push then doesn't work. Instead of .push, you will have to create a new copy of that array. So you use the spread syntax. So you spread the numbers into a completely new array, and you add the number next to it, for example, 4 or 10. And now the variable numbers and result are completely different. And this will let React know that, oh, we've actually changed, the state has changed and I need to re-render. So fixing our previous example, set data, instead of calling data.push, we should never mutate the original array. We should instead create a new copy of it. So if you want to take a short recap of all of this, never mutate the array, always create a copy of the array or a copy of the object so that React can detect that it has changed. And that's because internally it uses the triple equal to compare the previous state with the new state. And now onto the final one, and that is closures. So what's a closure? A closure is when a function contains another function. So you have a function definition, and inside of that function, you have another function definition. And in JavaScript, whenever a function exists in JavaScript, it will always have access to its outer scopes. It will always have access to the scope in the parent function. And this concept is called closures. So closures is not something you decide that you want to use. And it's honestly one of those concepts that seem complicated, but in reality, it's really not complicated. So at least the most common usages, you can get into complicated scenarios, but most of the times you will not really get there. So it's not something you have to enable or decide to use. Whenever you have a function, and inside of that function, you have an inner function, so another one, the inner function will have access to all the variables and the functions defined in the outer one. So what does this have to do with React? Well, as soon as you use events inside React hooks, you are defining a function inside a function. So the handle click function is defined inside the stopwatch. And so this is a closure, and that means that the handle click function will have access to the outer scope of the parent function. So handle click can actually access all the variables and functions inside stopwatch. So why do we care about that? Because handle click needs to use seconds and set seconds. And this is possible because of closures. So for closures, that's pretty much all you need to know in the context of React. Most of the times, it's going to be more than enough. So in conclusion, in my opinion, it's always better to understand the JavaScript concepts before diving into a framework, because if you had no idea what array, or at least just knowing that these concepts exist, if you had no idea what array destructuring means, then it's going to be confusing to use state. Why does the syntax look like this? Is this a React feature or is it a JavaScript feature? So, but of course, I don't mean you should spend years learning JavaScript. No, but just make sure that these concepts exist, spend a little bit of time on them, go to React, and if you get stuck, you can go back to them and then hop back into React. Alternatively, you can, if you decided to start with React first, when you encounter these JavaScript concepts, make sure to take a step back and learn them outside of the framework that you're using. All the examples that I used in this presentation are taken from react-tutorial.app. It's an interactive course that I've developed that teaches React step-by-step in around 80 chapters. So you really go from zero all the way to building an app with React Router and everything. So I hope you enjoyed this talk. You can find my slides on this link, and you can learn React interactively on this link. Thank you.
Thank you, Jad. Thank you so
Thank you.
much. That was really an insightful talk. because I myself work with hooks a lot and React. It was really an insightful talk. Thank you very much.
Awesome, glad to hear.
And
I think there's quite a lot of question. I saw the chat
yeah,
popping.
yes, there is a lot of question. Yeah. Okay, so let's go with the first one. So the first question is, should I learn classes or can I stick to hooks?
So should I learn classes or should I stick to hooks?
Yeah.
If you're learning React like right now in 2020 or next year in 2021, I would recommend you start learning with hooks first because it's easier, especially if you don't have a solid foundation in classes. So I used to find classes easier, but then after teaching React, I realized that for most people that don't have a strong foundation in classes, it's easier to work with hooks. And then if you will work at a company that is using classes, then you can learn classes after hooks, and it's going to be easier because you understand the concepts of React, but then you have to learn an extra layer for classes.
The next question we have is, what are the JavaScript concepts that I should be comfortable with before learning React hooks?
So functions, yeah, so anything except classes. So, oh yeah, okay. So there's also some non-JavaScript things that are coming from the DOM, from the browser, for example, fetch. I think it's important to know fetch because that's something you're most likely going to use in React. Function definitions, the ones I mentioned here, so array destructuring, object destructuring, closures, immutability. So how do I immutably add something to an array? How do I immutably delete something from an array? Same thing for an object. And let and const, though I think I saw a question about var, though it would also work with var, but you would avoid quite a lot of problems if you just stick to let and const.
Thank you for that answer. And the next one we have by Federico. He's asking, why should I use const instead of var?
Yeah, so the short answer, so why should I use let and const instead of var? The short answer is that you will not fall into unexpected gotchas with var because var has hoisting. So if you console log a variable before defining it and then you define it afterwards with var, it will actually log as undefined rather than break. That's because the interpreter is hoisting it to the top, which means it literally moves the definition all the way to the top. And this is a confusing concept for variables. I think the only place where it makes sense is for functions. So functions are also hoisted, which is why if you define a list of functions, you can call them before defining them. And this apparently is something we expect as programmers. But with let and const, there's no hoisting. So then you have this expectation that I define a variable and then I have to use it afterwards.
We have one more question that says .concat has a linear ON time complexity. Which immutable data structure do you advise for O1 O log n, which looks up reads and writes both?
To be honest, this is I'm so bad at algorithms and this kind of performance. So I do specialize in web performance, but not this kind, not the kind for big data. So I don't really know the answer. I would advise, though, if you're not working with a huge data set, to not worry about it. If you're working with 100 or 1,000, it shouldn't be a problem, unless this is something running on a key press event or something running extremely frequently. But even in that case, I would recommend debouncing it.
Thank you. I think that's all. We don't have any other questions. I would like to thank you so much. That
Thank
was
you.
a really insightful talk, and we have a lot of great comments that they had learned a lot. So thank you so much.
Glad to hear. Thank you.